According to recent industry research, roughly 88% of AI agents never make it to production. Everyone is talking about agents, every company claims to have one, but almost nobody can explain how they actually work. And a lot of the explanations out there are oversimplified or just wrong. Today I'm going to show you the real architecture, no buzzwords, no marketing slides, just how it actually works under the hood. Here's what happened. The word agent became the hottest term in AI. Gartner estimates that only about 130 out of thousands of so-called agentic AI vendors are real. The rest? Agent washing, slapping the word agent on chatbots and automations. So let's cut through it. By the end of this video, you'll understand the actual architecture, why most agents fail, and what separates the ones that actually work. Subscribe if you want more no-hype AI breakdowns. Let me give you the simplest, honest definition. A chatbot is one LLM call. You ask a question, you get an answer. Done. An LLM wrapper adds tools. It can search the web or call an API, but it still runs once and returns. An agent is an LLM calling tools in a loop until the job is done. That loop is everything. It's what separates a real agent from a chatbot with extra steps. The agent observes the result of its last action, reasons about what to do next, takes another action, observes again, and keeps going until the task is complete. Think of it this way, if you ask a chatbot to fix a bug, it gives you code. If you ask an agent to fix a bug, it reads the file, writes a fix, runs the tests, sees they fail, reads the error, tries a different approach, runs the tests again, and keeps going until they pass. That loop. Observe, reason, act, observe. That is the core of every real agent. Let's get technical. And instead of abstract diagrams, let me walk you through a real example. Say you ask Claude Code to fix a failing test in your project. Here's what actually happens. Step 1. Perceive. The agent gathers its current state, your message, the file structure, any previous context. Step 2. Reason. All of this gets sent to the LLM. It looks at the task, looks at its available tools, read file, edit file, run terminal command, and decides what to do first. And here's a critical detail most explanations miss. The LLM does not execute anything. It outputs structured JSON that says, read this test file. That's it. Text in, text out. Step 3. Act. The agent framework, not the LLM, parses that JSON and actually reads the file. The LLM never touches your system directly. Step 4. Observe. The file contents get fed back into the LLM's context. Now it sees the test code, spots the issue, and decides to edit the file. New JSON output. Edit line 42, change X to Y. The framework applies the edit. Result fed back. Then the LLM decides to run the tests. JSON output. Run NPM test. The framework runs it. Tests pass. The agent returns the result to you. That was 4 iterations of the loop. Perceive, reason, act, observe. 4 times. Production agents typically cap at 10 to 50 iterations before stopping. This pattern has a name, REACT, reasoning plus acting. Introduced in a 2022 research paper, it showed around 71% improvement on interactive tasks in benchmarks. There are other patterns too, plan and execute, reflection. But REACT is the foundation that most production agents build on. Now let's talk about what everyone gets wrong. 3 big misconceptions. Misconception 1. Agents can reason. They can't. Not really. LLMs are very sophisticated pattern matchers. When researchers change simple details in test problems like adding a detour to a map, model accuracy collapsed. A person who understands directions wouldn't be fooled by a detour. An LLM is, because it's matching patterns from training data, not actually thinking through the problem. Newer models like OpenAI's o1 are getting better at this, but traditional LLMs don't genuinely reason. They approximate it. Misconception 2. Agents are autonomous. Research on corporate deployments shows that roughly 68% of production agents perform fewer than 10 steps before needing a human. The word autonomous is doing a lot of heavy lifting in marketing that reality doesn't support. Even the best coding agents, Claude Code, Copilot, keep humans in the approval loop. Misconception 3. If the demo works, it's production ready. This is the one that burns the most teams. Here's the math. If your agent is 95% accurate on each step, which is pretty good, a 10-step task only succeeds 60% of the time. A 20-step task? 36%. Errors compound. Every step multiplies the chance of failure. Demos use clean data and simple paths. Production hits API timeouts, partial failures, inconsistent state. An agent that works perfectly in a demo can fail half the time on real data. So, what does an agent that actually works look like? 3 patterns keep showing up. First, they solve one specific problem. The most profitable agents in 2026 are not the most sophisticated. They solve a specific, painful, repetitive problem, and do it reliably enough that humans stop thinking about it. Claude Code is a great example. It doesn't try to manage your project, write documentation, and deploy to production all at once. It focuses on coding tasks, reading files, editing code, running commands. And it does that well. Second, they keep humans in the loop. Claude Code requires approval before every file change. GitHub Copilot's coding agent writes code and opens PRs, but a human reviews them. The pattern is the same. Let the agent do the work. Let a human approve it. Full autonomy sounds exciting, but the teams that ship working agents don't chase it. Third, they stay simple. Many production teams opt for more controlled, lower-level implementations rather than relying on heavy frameworks. That sounds counterintuitive, but high-level abstractions can make debugging harder. When your agent fails at step 7 of a 12-step task, you need to understand exactly what happened. Frameworks like LangGraph and CrewAI have their place, especially for prototyping, but in production, teams want control, and the costs are real. Running a production agent can cost thousands of dollars a month in API calls and infrastructure alone. Research suggests most companies underestimate their AI infrastructure costs significantly. If you're building agents, budget for it. So, what should you actually do with this information if you're building agents? Start with a single-purpose agent that solves one painful problem. Don't build a multi-agent system on day 1. Single-purpose agents can show value in weeks. Complex multi-agent systems usually fail when they can't demonstrate ROI within 6 months. If you're evaluating agent products, ask one question: does it actually loop? If a tool calls an API once and returns a result, it's not an agent, it's a wrapper. The loop is the test. If you're a developer trying to understand the space, here's what to learn. The React pattern is the foundation, an LLM, a set of tools, and a loop. That's the core architecture. Here's what it looks like in pseudocode. While task is not complete, send context to LLM. LLM returns a tool call, execute the tool, feed result back, repeat. That's it. That's the whole thing. Every agent framework, every product, every autonomous AI is a variation of this loop. The differences are in the details, how memory works, how tools are defined, how errors are handled, but the loop is always there. And be skeptical of any product that calls itself an agent without explaining what's looping under the hood. Gartner predicts over 40% of agentic AI projects will be canceled by 2027. Most of them were never real agents to begin with. That's how agents actually work. Not magic, not sentient AI. An LLM in a loop, calling tools until the job is done. Simple architecture, hard engineering. If you found this useful, drop a comment and let me know. Are you building agents or still evaluating? I read every comment. This channel breaks down AI tools and concepts for developers every week. No hype, just how things actually work. Subscribe, and I'll see you in the next one.